little bit complicated.
Okay,
A
Miss.
little bit complicated. Ada yang okay. So yang complicated tu, yang confused sikit tu, we will settlekan today lah. Okay, so far so good, Miss. Okay. Alright, so lupa pula saya kena share screen ni kan. Saya join meeting. VSU FVAR RZP. Share screen. Okay, start guys. My pencil. Tak okay. Okay, tak apa. Okay. Sikit. Alright. Jom start. Okay, so let's start with tutorial questions for chapter 2 atomic structure. So tadi kat dalam group kan saya letak poll kan, and you guys pilih mana yang susah, and turns out nombor 3 paling banyak orang ada masalah lah. So kita briefly go to number 1 and 2 dulu. Just briefly. So ni. So for number 1, we ask you to describe Bohr's atomic postulates. So in your notes, there are 4 postulates that you need to know and understand. So just take that. Okay, just ambil isi dari situ lah. Anyone want to share with us one of the postulates? Boleh tak?
Electron move in circular orbits about the nucleus. While moving around the nucleus, the electron does not radiate or absorb any energy. The energy of an electron in a hydrogen atom is quantized. That is, the electron has only a fixed set of allowed orbits called stationary states. Energy of an electron is quantized if it has a specific value.
Okay, alright. So there are 4 postulates. Okay, so 4 postulates. So the 4 postulates tu ada tak yang awak tak faham? Antara 4 tu, ada tak yang macam confusing?
Tak ada.
Boleh maksud saya?
No.
Ada, tak ada? No. Okay, so it's clear, okay? So, back to our tutorial. So, awak just letak je lah 4 postulates tu, okay? And then number 2, how is the second line of bracket series produced? So, first awak kena buat macam mana ni? Macam mana nak tahu? The second line of bracket series tu produced by apa? Pergerakan apa? Transition of?
Electron.
Oh.
Yes, true. So transition of electron daripada lower level to higher level atau higher level to lower level?
Higher level.
Higher level to lower level.
Okay, very good. So dia akan ada line produced bila electron tu dia fall down daripada excited state to any other energy levels. Okay, baru ada photon emission, baru ada line dalam awak punya spectrum tu. So untuk bracket series, what is the end final?
2.
Awak akan turun
2.
2 ke?
2.
Are you sure?
Yes.
Bracket.
4.
Lyman.
4.
Balmer. Person. Bracket. So it is n equals to 4. Okay. Okay, so n equals to 4. Okay, let's see. Kalau second line, kalau first line, dia kena turun daripada which level to level 4?
5. 5.
Okay.
5.
So level 5. Yes. So maksudnya kalau second line, dia punya n initial is
6. 6.
6.
6.
6. Okay. So anyone want to tell me the ayat? What is the ayat that you want to use? How is the second line of bracket series produced? The second line of bracket series is produced when electron
False.
apa? Electron
False.
falls, yeah,
Level.
from energy level 6 to
6 to 4.
6 to energy level 4, okay, atau to the fourth orbit atau fourth shell. Tapi energy level tu macam lebih common lah orang guna, okay. So the second line is produced from that, okay. So itu jawapan dia. Next, B. First line of Balmer series has a wavelength of 656.3 nanometer. So dia bagi tahu it is Balmer series. Kalau Balmer series kita tahu tak dia punya N ke berapa?
Tahu.
And final dia
Dua.
apa? 2.
Two.
Okay, first
Two.
line maksudnya yes. So initial
3.
dari
3.
what level?
3.
3.
3.
Okay, good. Very good. Okay, thank you. So has a wavelength of 656.3 nanometer. Calculate its frequency. Frequency dia punya sign ialah mu, macam V ni. Okay. So kita nak cari frequency. What formula can we use? And we have the wavelength, lambda. What formula do you use?
Yes.
Lambda equal to C.
Lambda equal C over V.
Okay, so because we know that V equals to, lambda equals to C over V. So awak rearrange to find the frequency. So mu V equals to C over lambda, okay. So awak punya C is speed of light, which is berapa? 3.30
0
times
10 to the power of 8.
10 to the power of 8 meter per second over your lambda. Your lambda will be 656.3 times 10 to the power of negative 9 sebab dia adalah nanometer, okay. So nanti awak tekan je, dapatlah terus frequency. So your frequency must be in per second, okay, per second. Ikutlah awak punya unit daripada awak cancel tu. Awak cancel M dengan M. Teng. So dapatlah. Okay.
Miss, bukan
Okay, so
C tu 3.0 je.
Ya.
3.0? Oh yeah. Okay. So
3.0.
3.0 lah. Saya tak ingat. Okay. Thank you dah. Okay. C. Calculate the wavelength in nanometer. Energy, maksudnya delta E, and frequency mu of the fourth line in Balmer alignment series. So yang ni macam ni kita nak cari. First kita kena buat apa? Kita kena tentukan apa?
Energy level.
Daripada alignment series.
Energy.
Yes, betul. Energy level.
Energy level.
So, and final for alignment series, what level?
1.
1.
1. Okay, good. Fourth line maksudnya and initial dia berapa?
5.
5. Sebab kalau first line is from second level, second line is from third, dia turun ke 1, 4 to 1, 5 to 1. So the fourth line is produced when 5 5 to 1. So the fourth line is produced when electron fall from the fifth level to the first level. Okay, that produces line in the fourth line in alignment series. So dari situ next kita nak cari apa tu? Kita dah ada initial dengan final.
Lambda.
Then kita nak cari apa?
Wavelength.
Lambda. Okay. What formula? 1 over lambda
1
equals to
RS.
R hash.
and then bracket
Nine.
1 over
N1 square.
N1 square minus 1 over N
2
2
square.
2
square.
square.
Where your N1 is smaller than N2. So kenapa kena obey this rule? N1 smaller than N2. Because
Supaya-
awak punya wavelength, yes, Brandon, kenapa?
Supaya
Supaya?
positif.
Yes, betul. Sebab awak punya wavelength mana ada positif mana ada negatif kan? Wavelength tu panjang, dia skala quantity awak belajar dalam physics. So awak nak dapat jawapan yang positif, okay? So then awak masukkan je lah RH awak, what RH will you use when you are using this formula yang ada wavelength? Wavelength akan dalam meter, betul tak? So RH awak yang mana satu awak guna?
1.0.
1.097 times 10 to the power of 7.
1.097. Okay, 1.097 times 10 to the power of 7. Apa form unit dia? Per
Per meter.
Okay. So, kena guna yang ni, yang per meter, negative 7 eh. Okay, per meter because we want to get our lambda wavelength in meter, okay. So, masukkan je lah awak punya values N1 dengan N2 tu, lepas tu nanti awak akan dapat 1 over lambda sama dengan whatever value, and then what you're going to do is to get lambda is to terbalikkan lah yang ni to the power of negative 1 atau buat 1 over this answer. Okay, so nanti awak punya lambda will be 94.95 nanometer. Okay, ada orang susah nak dapat tu? Ada tak?
Saya.
Okay, kenapa? Number 2. Oh, I didn't do number 2. Kenapa? How? Should we do it together? Should we?
Yes.
Okay. Okay, kita buat So, saya just take screenshot, copy. Dengar bunyi ayam. Okay. So kita nak cari wavelength. Okay, so 1 over lambda equals to RH 1 over N1 square minus 1 over N2 square, where your N1 is smaller than N2. So, macam ni kita nak tentukan N1 siapa, N2 siapa. So, to form the fourth line in alignment series, we will take the smaller number, which is 1 to be N1. Okay, ni N1 equals to 1. N2 is the bigger number, which is 5. Okay, and then kita masukkan RH tadi berapa? 1.097 times 10, negative 7 per meter. Betul?
Positive 7.
Positive 7.
Positif. Positif, negatif?
Negative.
Positif.
Positif lah.
Positive.
Positif. Okay. So, 1 over 1 square minus 1 over 5 square. Okay. And then tekan ada berapa? Tekan calculator dapat berapa?
1.0531200.
1.0531 times 10 to the power of 7. Betul?
Ya.
Meter.
Yeah,
Around
yes.
Okay. Okay, so what you're going to do next is lambda. Kira awak tukarlah tempat ini dengan ni. Okay. So 1 over that and you will get 9.4957 times 10 negative 8 meter. Okay. So jawapan dia nak dalam nanometer. How do we change it into nanometer? We will take down this number 9.4957 times 10 negative 8. So kita akan letak nanometer, okay, untuk cancel out, times 10 negative 9 nanometer. Faham tak? Awak tambah ini. Okay, awak tambah ini. So, then what will happen is that awak akan kalilah yang ni. So, minus 8, minus 9 dapat berapa?
10.
Minus 8, minus 9 dapat berapa? Minus times 10 negative
1.
7.
17.
17.
Negative 17.
negative 17.
Bukan times
Kan?
10 to the power of 9.
Times 10 to the power of
Oh, positive 10, 9.
maths.
Negative 17 kan?
17.
Negative 8 minus negative 9 equal to negative 17.
Tak, kita kena guna times 10 to the power of 9.
Yeah,
Because
positive 9.
nano ialah times 10 to the power of negative 9. So kita
Oh, sorry.
Betul.
Times 10 negative 9. Okay. Ini 10 to the power of 9. Okay. Thank you, Brandon. So, maksudnya kita akan dapat 10 je lah. Nanometer. So, pasal awak tukar 9.4957 kali dengan 10, you will get 4.957 nanometer. Okay.
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 Okay, Miss.
Alright, next. Delta E ke frekuensi kita nak cari sekarang. Kita dah ada lambda. Kita nak cari mana dulu?
Frequency.
Frequency, okay. So, frequency equals to C over lambda. Or just guna this formula. So, masukkan awak punya speed of light, which is 3.0 times 10 to the power of 8 meter per second over your lambda. 94.957 times 10 negative 9 meter. So make sure awak tukar dia jadi meter lah sebab awak nak unit yang sama. Okay, and then awak akan cancel the meter and your answer will be in per second. Berapa awak dapat tu?
3.16 times 10 to the power of 50.
15. Is it?
Yeah.
Yeah.
Per second. Orang lain? Boleh? Everyone?
Boleh.
Okay, so dapat dah awak punya frequency. Next, we want to find our delta E. So, what formula can we use daripada information yang kita dah kira ni? Mana? Awak nak gini mana?
HC per lambda.
H mu.
H mu boleh, HC over lambda boleh. Okay. So, kalau H mu awak just masukkan je lah. H awak apa? Planck's constant 6.63 times 10 to the power of negative 34 joule second times mu awak 3.16 times 10 to the power of 15 per second. So nanti jawapan awak dalam joule, okay? Awak dapat berapa tu?
2.095 times 10 to the power of negative 18.
Okay. Kalau awak guna delta E equals to HC over lambda pun boleh. Kalau awak guna formula lagi satu apa? Delta E equals to apa formula lagi satu? Yang Rydberg equation. Negative RH Hello?
What, Miss?
Hello?
Yes.
RH
Rydberg equation punya formula. RH
R hash bracket 1 over n1 square minus n 1 over n2 square.
Betul ke formula tu?
Yeah.
Betul.
Yes.
Okay. Alright, so awak boleh guna any of the delta E punya formula, okay, to find the energy change. Alright, so that is number 3. So you should get the answer. So number 2. So now number 3. Ini banyak orang tak tahu macam mana nak buat. Okay, let's look at the question. So with reference to the table below, okay, you are given the color of line spectrum. So maksudnya dia ada color, so dia dalam visible region, okay. And then you have your wavelength, right? It is in nanometer, your lambda, okay. So now you want to calculate the energy emitted, maksudnya energy release. So maksudnya awak punya delta E will be negative, okay. Sebab dia kata energy emitted, kalau tulis energy released, okay, if you write energy release is awak bagi value je. Kalau awak tulis delta E, which is what we are going to calculate, your answer awak kena letak negatif kat depan. Okay, sebab negatif tu tells you that energy is released, right? Bukan absorbed. So energy emitted in the formation of red line and green line. So you are given the wavelength of red and green line. Okay, so what can we do? We can use the formula that is to delta E equals to HC over lambda. Okay, so yang ni awak just masukkan je lah. HC Planck constant kali dengan speed of light over your lambda. Make sure that you change nanometer to meter, okay, and letak negatif kat depan because you want the answer your delta E to be negative, okay. So maksudnya energy emitted, energy released. So this is the answer for 3A. Okay, yang tu tak ada masalah kan 3A?
Yeah.
No.
Okay. Okay, good. So we move on to 3B. Sketch the energy level diagram to show transitions of electron that produce red, green, and blue lines. So from this question, what do you think that you need in order to sketch an energy level diagram? Dia cakap energy level diagram maksudnya awak akan ada energy level lah. So energy level tu is your N, tu lah your orbit. So maksudnya awak akan ada, okay, saya guna warna merah. Macam ni, okay, awak akan ada energy. Lepas tu awak akan ada dekat atas ni, awak akan ada yang tebal, which is N equals to infinity. Lepas tu awak makin lama awak punya apa ni nama dia, your gap of your energy level makin besar. Okay, so make sure awak punya gap tu makin lama makin besar. Okay, so awak tulislah dekat mana awak nak start daripada N equals to 1 and then N equals to 2. Awak kena apa ni, label lah. Okay, so maksudnya okay, kita kena tahu kita punya energy level di mana to produce red line. Okay, elektron awak akan fall daripada N berapa, okay, N initial dia to N berapa, N final dia. Kita tahu tak N final? Do we know the final energy level? Awak punya line spectrum ni series apa? Okay. Series apa? Macam nak tahu? Okay, dia adalah Balmer, okay? Balmer series because you have colours. So maksudnya dia adalah in the visible region. So kalau Balmer series, maksudnya N final awak will be
2.
energy level
2.
2. Okay, yes. Energy level 2. So maksudnya all your electrons daripada atas akan turun energy level 2. Okay. So let's find how to find the initial. Okay. N initial. Okay, atau N1. Okay, N initial untuk form red line, green line and blue line. Okay. So kena cari ni semua. Awak punya N final atau N2 dah tahu dah. It is 2. So, we will use the formula. Okay, since we are given the wavelength. Simple.
Miss dekat airport ke tu, Miss?
Itulah, dia tertinggal ni, dia tertinggal saya nak bawa balik. Okay, wavelength, kita dah ada wavelength kan? So maksudnya kita guna this formula, okay? 1 over lambda RH equals RH 1 over N1 square minus 1 over N2 square, where N1 is smaller than N2. So you will be using this formula, okay? 1 over lambda, let's say to find your rate, kita akan masukkan lambda and then awak masukkan RH, okay? Rydberg constant awak is the one yang ada per meter the unit, okay? Because you are using lambda kan? So kat sini sebenarnya meter. So and then awak masukkan, awak punya N1 is 2 square. Okay, your N1 is 2. Okay. So your N2 is the one that we want to find. Mana saja pun dah lalu kat rumah saya kan? Okay. So N2 is what we want to find. Okay, so ini adalah maths lah. Awak kena pandai pindah-pindah. Okay. So daripada sini, what I did first is saya bawa yang ini, saya punya Rydberg constant, bawa turun bawah. So kali dengan ini, 6 awak punya lambda. Okay. So dapat ni. So and then saya tolak yang ni pula. Okay. Saya bawa ni pergi sebelah, yang ni bawa pergi sebelah. So kita dapat 1 over n square. Okay. Kira ni. And then what I did was yang n2 square tu kita akan square root lah. Okay. So jawapan yang 9 tu tadi kena square root. So dapatlah n2 awak 3. Okay. Ada yang dapat tak? Ya, iklan tu. Ada yang dapat awak punya N2?
Ada.
Ada lah.
Okay.
Dapat.
Yang tak dapat kenapa? Yang tak dapat kenapa susah? Tak dapat kenapa? Sebab tak tahu kan benda formula ni. Sebab tak tahu benda formula ni ke?
Tak dengar, Miss. Miss dia terbangun.
Okay. Yang tak dapat sebab apa? Yang tak dapat
Tahu.
tak tahu guna formula ni. Okay, so sekarang awak tahu nak guna formula apa? Okay, so itu untuk cari red. So awak kena cari lah untuk green, untuk blue. Okay, so kalau awak kira-kira, okay, you should find that awak punya N2 untuk green line, okay, to form green line, dia fall from energy level 4 to 2. For blue line, dia fall from energy level 5 to 2. Okay, so awak kena carilah awak punya N2 tu guna this formula. Alright, so now we want to sketch our energy level diagram. Tak faham lah. Kenapa?
Speaker background, Miss.
Diorang tengah praktis kot kan?
Suara apa tu?
Suara pesawat.
Ah, pesawat.
Oh,
Miss kan dari langit.
tinggal dekat dengan airport.
Ya, rumah saya 20 minit je dari airport. Tapi ini takkanlah plane tu saja nak pusing-pusing kat sini kan? Ni
Mungkin ada
udara kot.
knowledge sudah balik pelabuhan dah.
Ada ke? Dia lalu lagi. Okay. Dah, jangan lalu dah. Okay. Sekarang kita sketch our energy level diagram. Okay. So, first you will draw a line for your energy. So, ini adalah energy. Okay. And then you will draw your n equals to infinity atau start dari bawah. So, kita akan start dari pada n equals to 1. Okay, makin lama awak punya line daripada bawah, dia makin kecil dia punya gap. Okay, so ini n equals to 2. Lepas tu n equals to 3. Sorry. Okay, n equals to 3. N equals to 4. N equals to 5. Okay. So kita nak berapa? Kita at least kena ada sampai n equals to 5 kan? So nanti dekat atas ni sekejap buat dia makin kecil. So buat line tebal. Okay. Line tebal. This is n equals to infinity. Okay. Okay. So yang kanan ni adalah awak punya energy level lah. So sekarang kita akan draw kita punya electron dia punya transition daripada which level to which level. So kita buat for red line first. Your electron drops from n equals to 3 to n equals to 2, okay? So n equals to 3, so draw the release. Sorry. Oh Lord, why Lord? Okay. N equals to 3 to n equals to 2, so this will produce your red line. Oh, so it's going to be red. Okay. And then for green line, it is from n equals to 4 to n equals to 2. Green. And blue line is n equals to 5 to n equals to 2. Blue. Okay? Okay, complete tak? Ada
Complete.
yang dapat buat ni?
Complete.
Okay, macam ni eh. So this is how you draw you sketch your graph. Okay, oh dalam jawapan tu dia tulis macam ni. Bawah ni tulis red. So mana-mana pun boleh lah. Asalkan awak bagi tahu. Okay. Alright. So dah. Next. So after number 3 is okay, number 4. Number 4 boleh buat tak? Number 4. Figure below shows the Lyman series of hydrogen emission spectrum. So kalau Lyman series kita tahu dia punya n final berapa?
1.
Portable 1.
One.
Okay. Yes, so this is your line spectrum. Okay, from your line spectrum, we want to label the low and high energy ions. So maksudnya awak punya energy delta E lah tu. Okay. Mana yang paling tinggi energy dia, mana yang paling rendah. Okay. But first things first, daripada line spectrum tu, you need to know which line is the first line. So Adakah yang paling kanan atau yang paling kiri?
Yang
Kanan.
paling kanan.
Okay, kanan ni
Kanan.
first line. Okay, why is it the first line? Why?
The gap.
Macam energy.
Blank.
Yes, the
Wavelength.
gap. Dia ada gap paling besar, wavelength paling tinggi. Okay, so sekarang sebab kita nak tahu mana low energy N dengan high energy N, kita akan tulis wavelength mu energy. Okay, so going to the right going to the right, ke kanan. Awak punya wavelength makin tinggi. So going to the right. Okay, kita akan tulis macam ni. Kenapa tu? Ish. Kenapa tu? Okay, damn it. So delta E equals to H mu equals to HC over lambda. So when your wavelength increase, okay, that means your mu will decrease. Sebab satu kat bawah, satu kat atas. Okay, so delta E akan increase ke decrease? Bila wavelength increase,
Decrease.
E will
Decrease.
decrease. Okay, so maksudnya awak tulis je lah kat tepi ni. Mu decrease, energy decrease juga. Okay, so sekarang kita nak label the low and high energy N. So on your right ni, adakah dia high atau low energy N? Kalau ke kanan, makin kurang energy awak.
Low.
So maksudnya this is your
Low.
okay. Good, low energy N. So yang kanan ni maksudnya is the high energy N. Okay, macam tu je lah. Next, draw the electron transition of lines P, Q and R on the energy level diagram of the hydrogen atom. So yang ni boleh buat tak? Dia sama macam tadi kan? Betul tak?
Ya.
Betul? Okay,
Yes.
kita dah tahu. We already know that the first line, this is the first line and the final energy level is 1. So that means yang first line ni awak punya N dia fall dari mana? I mean awak punya electron fall dari mana? N equals to
2.
2.
2.
2. And then this is from N equals to 3, N equals to 4, N equals to 5, N equals to 6 and so on. Okay, dekat sini panggil nama dia convergence limit. Okay, kat situ bila awak punya elektron makin jauh. Alright. Okay, so sekarang kita dah tahu N initial dia. So kita boleh draw tak the electron transition of lines P, Q and R? Boleh? Boleh
Boleh.
draw it?
Boleh.
Okay. Okay, macam tadi So maksudnya P is from N equals to 5 to N equals to 2. P, Q, R, N equals to 5 to N equals to 2, N equals to 4, N equals to 3. Betul tak? P, Q, R. Okay, betul lah. So, awak akan draw macam tadi. Guna pembaris. Ini adalah energy. Okay. Then you will start with N equals to 1. So, N equals to 2. N equals to 3. N equals to 4. N equals to 5. Kalau nak letak N equals to 6 pun boleh. So dia makin lama makin rapat. Okay. Ni awak kena lukis dengan kemas lah. Ni N equals to infinity. Okay. So just turunkan. For P it is from N equals to 5. So daripada 5 here. Turun bawah. To N equals to 2. Okay.
Bukan sampai N equal to 1.
Ha? Oh ya, alignment kan? Sorry. Simon eh?
Yeah,
Yes.
line series.
Yeah, amen.
Okay. So n equals to 5 to n equals to 1. So this is P, n equals to 4 to n equals to 1, Q, and R. Okay. So macam tu je. So semua orang dah pandai nak sketch energy level diagram?
Yes.
Okay, good. Calculate the energy responding to line Q. Maksudnya dia nak cari apa tu? Delta E.
E.
Delta E.
Okay, delta E, okay. Sebab dia bukannya cari energy of electron at orbit specific. Kalau yang tu awak guna En equals to negative RH times 1 over n square. Kalau ini dia minta energy to line. So line tu dia form bila ada transition of your electron from different energy levels. So maksudnya itu adalah delta E, okay. So what formula you want to use? Delta E equals to
RH bracket 1 over n1 square minus 1 over n2 square.
and 1 square minus 1 over n2 square. Okay, so awak punya n1 apa? Awak punya n2 apa?
N1
Untuk cari
4.
line Q,
O.
n1 is
4.
4.
n1 is 4, n2 is
1.
1.
Okay. RH awak dalam unit apa? Joule
Joule.
second kan?
Joule.
Apa awak punya RH? Joule. Joule. Okay, yang Joule because awak nak energy. Okay, bukannya wavelength. So use the correct terms, masukkan and you will get your delta E. Okay. So number 5 okay tak? The difference in energy between second and fourth energy levels of hydrogen atom is blah blah blah. Calculate.
Boleh.
5. Ini boleh? Ada tak orang yang tak boleh buat? Ada yang ada masalah tak dapat jawapan?
Tiada.
Tak ada?
Tak ada.
Okay. So yang ni awak punya formula apa? Kita nak cari wavelength, frequency, bila awak punya electron transition from n equals to 4 to n equals to 2. So dia adalah Balmer series. So for wavelength awak guna formula apa? 1 over lambda kan?
Ya.
Yes.
Ya.
Kan? Okay, so yang tu awak guna formula tu. Lepas tu dah dapat wavelength, awak boleh cari frequency guna frequency equals to C over lambda. Okay. Lepas tu, tu je lah. Dapat lah. Okay. Next B, energy emitted by 1 mole of electrons for the above transition. So, maksudnya apa ni? Dia cakap apa? For 1 mole of electrons. So, what do you have to do?
IE.
Macam mana nak buat? IE ni? IE ke tu?
2 times 10 to the power of 23.
Okay, so ini bukan IE So ini bila dia cakap for, ini still energy emitted. Kalau IE memang awak akan kat belakang tu 1 over n square and 1 square minus 1 over n 2 square where your n2 will be infinity. So nanti awak akan dapat value minus 0 macam tu. So itu adalah IE. Okay, and then awak kena kali dengan Avogadro's constant sebab ionization energy memang dia minta untuk 1 mole. Okay, 1 mole of electron remove. So memang awak punya jawapan memang dalam kilojoule per mole. But for this question, okay, dia kata energy emitted by 1 mole of electrons ni, it is for delta E, okay. Tapi dia nak 1 mole. So yang tadi ni kita bukannya untuk 1 mole. So sekarang untuk 1 mole kita akan kali dengan Avogadro's constant, okay. Which is 6.02 times 10 to the power of 23 per mole. Okay. So awak just kali awak punya jawapan daripada sini yang delta, awak kena cari delta E. Okay, sorry. Awak kena cari delta E dulu. Okay. And then kali dengan Avogadro's constant. Okay. And then you will get this answer in kilojoule per mole. Okay. Kena ada per mole. Boleh?
Boleh.
Okay, good. So next, number 6. Ada masalah tak? Ionization energy. Okay, kita buat lagi. Tak ada. Okay, yang ni guna formula apa? So since kat sini, okay, yang ni awak diberi wave number. Wave number. Okay. Wave number. So wave number is not the same as wavelength, okay? So wave number tu apa? Wave number is equal to 1 over your wavelength, your lambda. Alright? Okay. So how are we going to calculate the ionization energy of hydrogen from the spectrum? So kita nak ionization energy. Kita akan guna formula apa tu? What formula can we use when we are given the 1 over lambda?
EI.
Kalau EI, ionization energy. Okay. So kita akan cari delta E equals to HC over lambda. Okay. Tapi kita punya lambda tu kita nak guna yang mana satu? Yang paling kanan ke paling kiri untuk ionization energy? Ionize maksudnya awak punya electron kena buang to infinity. Paling
Yang
kiri, okay?
Kiri.
We will use, yes, very good. Kita guna paling kiri because dekat paling kiri ni adalah bila awak punya convergent limit. Okay? Bila awak punya electron dah kena remove, dia kena buang to infinity. Okay? Yang paling kiri ni sebab dia paling smallest gap. So, this one will be your lambda infinity. Wave number infinity, okay? Wave number infinity. So, bila dapat soalan macam ni kan, awak kena make sure lah dia tengok dia bagi dalam unit apa. Wave number ke wavelength. Alright? Kalau wavelength awak boleh terus masuk. Kalau wave number, awak kena kali macam mana?
1 over.
Maksudnya, okay, 1 over lambda, okay. So, awak just times H times C dengan awak punya wave number lah. Sebab wave number sama dengan 1 over lambda. So, masuk je lah this value. But don't forget yang you have 10 to the power of 6 per meter ni. Okay. So, masukkan yang tu and you will get your delta E. Okay, tu dapat delta E. Tapi ionization energy, dia mesti dalam in kilojoule per mole. So that means awak punya delta E kena times with Avogadro constant. Okay, baru dapat jawapan dalam kilojoule per mole. Alright, I mean dapat dalam joule per mole lah pasal tukar jadi kilojoule per mole. Okay. Okay, number 7. Give 2 weaknesses of Bose atomic model. Apakah weakness Bose atomic model?
Can only
Nota?
explain hydrogen spectrum.
Yes. Can only explain hydrogen spectrum. Lagi, can only explain
Spectrum of ion
species
with
with
1 electron.
1 electron atau ion with 1 electron. Mana saya punya ni? Cuba.
Electron are wave-like.
Yeah. Electrons are wave-like, so electrons have dual nature, like particle and wave both. Okay. Lagi satu Selin ke? Selin kot yang tanya saya, boleh ke guna yang apa? Electrons cannot explain. It cannot explain for the extra lines formed in the hydrogen spectrum. Yang tu boleh Yang tu boleh guna ayat tu. So jawapan dia, electrons are restricted to orbit the nucleus at certain fixed distances. It cannot explain for the dual nature of electron. And it cannot explain for the extra lines formed in the hydrogen spectrum. And the rest lah juga yang ni. Okay. Okay. So, dah habis? Okay, dah habis dah. Okay. Next. Soalan objektif. Apa jawapan awak? Choose the highest energy involved when an electron makes a transition. So, awak kena buat apa ni? What do you
B.
have to do for this question?
The
Kena
drive
cari energi dia.
Energi dia.
energy.
Awak kena cari energy dia. Yang ni kan, for this question, you have to draw. Okay? You have to draw, awak kena draw energy level diagram. Lepas tu kan energy level, so N equals to 1, N equals to 2. Ni. Lepas tu awak kena draw line spectrum. Boleh? Awak kena draw line spectrum. So awak tahu yang daripada Lyman to Balmer and so on, energy awak makin besar ke makin kecil? Wavelength daripada Lyman to Balmer akan makin tinggi atau makin kurang?
Tinggi.
Makin tinggi. So awak punya energy akan makin
Kurang.
Kurang.
makin kurang. So maksudnya siapa antara Lyman dengan Balmer, siapa energy dia lebih besar?
Alma.
Limer.
Lyman.
Lyman.
Lyman, okay? Lyman. So that means awak punya jawapan C dengan D ni taklah. Okay. So kalau bila awak lukis line spectrum pula antara A dengan B, you will find that siapa yang dekat kanan, siapa yang dekat kiri, I mean like siapa yang lebih kurang gap dia, siapa yang lebih kecil gap dia,
N3.
A ke B,
B.
B.
N3,
B.
okay? N3 to N1, okay? Okay. So dia punya wavelength punya gap akan lebih kecil, so maksudnya energy dia lebih besar lah. So jawapan dia B, okay? Itu cara awak nak deduce untuk dapat jawapan ni. Okay, so yang tu 2.2. Ini calculate the wavelength for the fourth line in Balmer series. Yang ni kita akan guna formula apa? 1 over lambda kan? Betul tak?
Ya.
Okay, so awak guna
Ya.
formula tu and you will get your wavelength lah. Okay, so fourth line kalau Balmer series is n equals to, and final dia is n equals to 2. So fourth line dia n equals to berapa?
N equal to 6.
2, 3, 4, 5, 6. Okay, 6, okay. So 6, alright. So jawapan dia apa? Dah dapat tak? Nak panggil nama ni? Nama yang saya tak pernah panggil? Fever.
Panggil Ifa.
Ya,
Fah,
Miss,
ada
panggil
jawapan tak?
Miss.
A.
A.
Ada banyak Ifa lah sebenarnya dalam
A.
kelas ni. Jawapan dia A. Okay. So, ni awak kira lah sendiri, okay? So, make sure hantar malam ni. Right, so the rest nanti kita cover next week. Okay. Kita punya Google Meet nak break ke 5 minit? Kita sambung lah.
Ya.
Kita sambung. Boleh tak? Boleh tak?
Boleh.
Boleh.
Cuba tulis dalam messages. Okay tak? Boleh bertahan lagi? Boleh. Atau nak saya buat poll, nak saya buat video atau kita sambung Google Meet? Gitu. Macam boleh.
Mana-mana aja.
Video?
Video? Ada yang dah penat? Ada yang kena pergi somewhere?
Miss.
Lepas ni
Miss,
dia
lebih-
tulis.
Miss rasa lebih
Apa
senang
sorry?
buat Google Meet atau lebih senang buat video?
Buat video. Tapi jap. Saya kena record lah. Oh, ramai nak video eh. Saya okey je mana-mana. Tapi kalau video maybe ikut saya. Ramai yang nak video, saya rasa macam okey je video. Tapi ada tak? Tapi before kita end, saya nak tanya ada tak soalan untuk lab report tu dulu. Okay, kita tengok dulu. So basically, awak punya eksperimen ni, okay, back titration that means that you are, tiba sambung. Tiba sambung. So basically back titration tu, awak akan masukkan metal dalam acid, lepas tu dia akan react. Okay, dia dah dissolve dalam conical flask awak and then awak ambil solution. Maksudnya metal dah react dalam HCl awak. Okay, lepas tu HCl tu dia bagi tahu it is in excess. So maksudnya bukan semua HCl akan react. Okay, so bila dia tak habis react, maksudnya ada lagi lah HCl dalam awak punya conical flask. Lepas tu awak ambil that conical flask, awak buat titration pula dengan NaOH. Awak buat titration tu untuk tahu berapa banyak HCl yang left unreacted with the metal. Okay, siapa yang tak react dengan metal. Okay, kemain nak undi? Tak payahlah undi, video je lah. Boleh tak? Okay.
Boleh saja.
Boleh saja. Okay. Alright, so maksudnya saya buat video lah. Okay.
Miss.
So semalam
bagi
ya.
question tu. Bagi part
Question
exercise.
apa? Oh, ya. Okay. So maksudnya kita sambung for tutorial lah. So lab tu saya just buat video, okay?
Okay, boleh.
Tapi before that, awak punya lab tu ada tak apa-apa soalan?
Tak ada.
No.
Ada, tak buat lagi.
Ya, tak buat lagi.
Ada tak? Budak-budak ni. Dah ada seminggu. Okay, fine, tak apa. Next time, kalau saya bagi masa banyak sangat, make sure at least adalah buat juga, okay? Adalah mencuba, alright? Okay, so kita go to notes punya examples and exercises. Alright, so itu example 1 saya dah discuss dalam nota. Exercise. Okay, for this exercise, calculate the energy of hydrogen electron in the first, third and eighth orbit. What formula are you going to use?
1/n square.
1/n square. Is that the full formula?
No, RH 1/n square.
Okay.
Negative
En equals to negative RH
RH
1/n square.
square.
N square. Okay. So, ini just masukkan je lah awak punya N tu kan, betul tak?
Ya.
Okay. So, awak akan dapat jawapan dia. RH awak guna apa? Which Rydberg constant are you going to use for this RH? For this RH pula? For this formula?
2.8 times 10 to the power of negative 18.
Unit dia dalam?
Joule 2.1.
Joule. Okay. So because kita nak cari energy, so kena guna this Rydberg constant lah. Alright. So yang tu just masukkan je, lepas tu dapatlah jawapan dia. Okay. So number 2, calculate the energy change delta E that occurs when an electron falls from n equals to 5 to n equals to 3 energy level in a hydrogen atom. So yang ni kita just guna this formula. So n initial dengan n final apa?
Initial 5.
Initial 5 and final is 3. So sebab dia fall daripada 5 to 3. Okay. So masukkan je formula awak. Awak punya RH apa? Which one will you use to find energy?
2.18 times 10 to the power of negative
Sama
18.
tadi. Okay. So itu 1/5 square. Minus 1/3 square. Okay, so tekan calculator dapat apa?
Negative 1.55 times 10 to the power of negative 19 joule.
Okay, betul?
Ya.
Betul.
So okay, bagus. So let's say kalau dia kata energy change in kilojoule per mole. So awak kena buat apa? Let's say kalau soalan tu cakap macam tu.
Tukar
Darab
jadi
nombor
6.02.
divide.
Okay, so if they ask you, yes, divide. Kalau dia ask you for in kilojoule per mole, you will times Avogadro constant, okay, Na. Okay, next, calculate the frequency and wavelength of the radiation emitted in question 2. So kita nak cari frequency and wavelength. Okay, kalau frequency, kita dah ada delta E, kita akan guna formula delta E equals to H mu. So cari V delta E over H. Okay, so masukkan je lah punya delta E and divide with Planck constant. So to find wavelength, you can use the formula lambda equals to C over V. Okay, so your answer will be in meter. Then you will change it to nanometer. Alright. Okay. Senang je kan yang ni? Sama tak oh saya tak letak jawapan ni. Betul juga jawapan awak. Aman dia tu. Okay, apa lagi exercise yang kita ada? Untuk exercise, next. Example tu saya dah cakap dah. Example 2. Okay, yang ni macam soalan tadi kan? State the transitions of electrons that lead to the lines W and Y respectively. So, Balmer series, awak punya and final berapa?
2.
2.
2. So, which is the first line in this line spectrum? Paling kiri ke paling kanan?
Left.
Kiri.
Left. Okay, so
Kiri.
this is kiri. First line. So, maksudnya for this first line, awak punya elektron jatuh dari n equals to 3. Ini n equals to 4, n equals to 5, n equals to 6, and n equals to 7. Okay, so awak tulis saja jawapan awak. The line W is produced when electron falls from energy level 4, n equals to 4, to n equals to 2. Betul? Next for Y, line Y is produced when electron transition from energy level n equals to 7 to n equals to 2. Macam tu je, okay? Okay. So next example 3. Example 3 dah ada jawapan tak saya bagi? Okay. So basically, we need to find the line with the longest wavelength of photon. So maksudnya kita akan minta wavelength energy mu, tapi kita nak cari wavelength lah. So which one has the longest wavelength? Paling kiri atau paling kanan? Kita akan tengok apa?
Kanan.
Kanan.
Paling kanan. Kita tengok apa? The gap.
Gap.
Yes. So this one, the gap is the widest. So this one will have the longest wavelength. Okay. So lambda paling besar, paling tinggi. Right. So line A is the line with the longest wavelength. Jawab dulu. So describe the transition. When you describe the transition, you have to describe daripada ground state. Okay. Maksudnya awak punya line A is formed when the electron absorb energy. Electron kat ground state absorb energy and promoted from n equals to 1 ke n equals to kejap. N equals to 3 tak silap saya.
From 4 to 3.
43. Okay. Okay, promoted from, ni daripada ground state dia dulu. You can start from ground state n equals to 1 or n equals to 3, apa-apa yang lower daripada n equals to 4. Okay, so let's say daripada n equals to 3 to n equals to 4, maksudnya bila dia promoted, dia naik, dia dah excited, the electron is excited at n equals to 4. Okay, and then the electron is unstable. Okay, so when the electron is unstable, it will fall back, okay, turun bawah to a lower energy level. Okay, so for Passion, it will fall to energy level
3.
n equals to 3. Okay, so it will fall to energy level n equals to 3 and release a specific amount of energy in the form of light radiation called photon. So the energy release is detected by a detector and a line A is formed on the spectrum. So ayat yang ni macam extra lah actually. Tapi ni macam the very very complete explanation lah to describe the transition that will give rise to the line. Okay? Alright. Boleh?
Boleh.
Maksudnya awak
Boleh.
kena explain daripada dia ground state to excited state and then they fall back baru dia produce line. Okay? Okay, so next exercise. Yang ni pun soalan macam nak dekat sama je dengan exercise yang kita buat, tutorial kita buat. Jawapan akhir dia for wavelength is 486 nanometer. Frekuensi dia slide ke berapa ni? Frekuensi dia is, ni awak note sekarang 6.1728 times 10 to the 14 per second. The energy will be 4.0926 times 10 to the power of negative 19 joule. Okay. Okay, yang ni saya rasa awak dah boleh buat lah. Dah pandai kan? Okay, for this exercise, ada tak orang yang dah buat? Exercise ni macam mana kita nak jawab ni? Use the Rydberg equation, Jordan, to calculate the wavelength. Aku nak tahu. Sorry. Okay. To calculate the wavelength of the spectral line of hydrogen atom when the electron drops from n equals to 4 to n equals to 1. So you know that this will be Lyman series. Right? So identify the series. So the line will be found. So to find the wavelength, I would just gonna the formula 1 over lambda equals to R H 1 over N1 square minus 1 over N2 square lah. Okay. So then you will find the lambda. It will be 97.23 nanometer. Okay. The series, boleh identify from here. Since dia turun to first orbit, that means that it is Lyman series. Okay. Okay, yang ni boleh buat. Dapat tak jawapan dia? Dapat. Okay, ada orang yang ada masalah? Tak dapat? Dapat. Okay, so semua orang dapat lah kot. Kan? So siapa yang tak dapat tu, tanyalah saya ke kawan-kawan awak. Alright. So exercise, ini example saya dah explain. Yang ni example 2 ni sama kan dengan example 1 ni, saya pun tak tahu kenapa saya letak. Okay. Tapi for this one, yang ni lain sikit. So this one dia bagi wavelength. Ini dia bagi wavelength. So kalau dia bagi wavelength, maksudnya awak boleh terus masukkanlah the answer. Betul tak? So the alignment to find the ionization energy. Okay. Kita nak tahu, kita akan guna formula apa untuk cari ionization energy? Yo guys.
Delta E time Avogadro number.
Delta E times Avogadro constant. Okay, kita kena ada dalam kilojoule per mole. Okay, jawapan in kilojoule per mole. Okay, for delta E, you will use delta E equals to
HC
R
over
H HC over lambda. Dapat jawapan sama ke kalau macam tu?
dapat.
Dapat? Okay.
Ya.
Okay, good. Okay, maksudnya awak boleh guna yang tu jugalah. Delta E equals to HC over lambda, where your lambda is 9.12 times 10 to the power of negative 8 meter. Okay, so masukkan je atau guna yang ni pun boleh. Kalau yang ni, okay, masukkan value RH. Ini will be 1 over, boleh ke cari N1? Oh, lemon series kan? Lemon series. Okay, so yang ni N1 awak akan jadi 1. Okay, 1 square. 1 square minus 1 over infinity square. Okay, so if you use this formula, okay, ni akan jadi 1 minus 0. Okay, so then you will get your delta E. So bolehlah guna yang ni atau yang ni, formula ni. Okay, make sure lepas dapat delta E, you times with Avogadro's constant because your ionization energy must be in kilojoule per mole. Right? Okay, dah. Habis dah. Betul? Habis dah?
Betul.
Okay, so do you have any other questions? Any
Tak ada.
problems? Oh, dah Zanda. So, with that, I think we will end our Google Meet and I will see you guys next week. Okay, so nanti video for lab discussion, cara calculation tu saya akan buat video lah. Saya akan buat video and upload for you guys. Okay, so I think that's all for today. Thank you everyone.
Thank
Thank
you,
you,
Miss.
Thank you, Miss.
Thank you, Miss. Thank you and bye bye.
Thank
Bye.
you, Miss.
Thank you, Miss.
Okay. No problem.
Thank you, Miss.
Okay.
Thank you, Miss.
Okay, udah. Okay, I'm going to end the call for everyone. Okay. Stop recording.